Okay, so we're live now. Let's see what's going on here. Oops. Not sure which channel I'm on, to be honest. Give me a second here. Display window. Window capture. Okay. Close. Okay, I think it's working then. Hi everyone, thanks for coming. Let me go and do application capture for that specific window for that. Oh yeah, I should do window capture for that specific one itself. The content live. I'm actually live now. Let me copy the link and give it to someone. Okay, this was just a bit of admin work on my part. Let's go and start off with the basics. So, okay, I'm just setting it to the stream link to all my friends. I don't think anybody's joined yet. Let me turn on the. Oops. Let me turn on the view. Little control panel or something. Yeah, good. Chat rate 1. Who's chatting? And nobody's chatting. You better not be chatting. There's literally nobody here. Let's also make this into a live control panel. This stays. So unfix this. Let's close the specific one. Okay. Hi everyone. Then. Okay, let's go through this. Nobody's here yet, so let's go through this. Let's go to question number. Yes. I'll paste the link in the chat to be. I don't know if it gets me flagged by YouTube. Let me not take that risk. Okay, so let's go through this. Yesterday we did this, right? And this was really fun because we got to see how to rearrange these. This is super fun, right? My height, weights. This is my original HWC. Right, height, width, channel is just to WHC. So it is like this. And then there's your height and width, and you're seeing it as the other way around now. So it gets like flipped, right? And you can see this happening here. So then we go to this thing called composition of axes, which is super fun. So what is happening here is that IMS is a 6 by 96 by 96 by 3. And we're combining the B and W. I did this myself just now. So what we're saying is that there's some 96 by 96, like 96 by 96, 96 by 96, and so on, 6 of these, right? And that's the batch. So what we're saying is that it's stacked, actually. You can think of them as like stacked 6, 96 by 96 matrices, and 6 of them stacked off each other. What I'm saying is I want to move this batch dimension, which is how many stacks are there. I want to combine it with my width, right? So my width now becomes 6. Like it becomes like this, which is why this original thing. So if we just do ims.shape, right? And this original thing is 6 by 96 by 96 by 3, and now this shape, right, becomes 96 by 576 by 3. That's because we multiplied this 6 by this 96. Okay? So the same thing's happening here, but we're doing it by the height. We're we're doing that. It's not an easy concept to grasp, so I don't think what's happening here. And we're seeing what's going on here. And then if you see this, it just means nothing, right? It's just an array. My very nice display numpy's images doesn't work. So that's what's happening here. Then we can do this thing called decomposition. So decomposition means I take my B, which is B6. I decompose into B1 and B2, and then now I can compose these like just now I did the composition here, the new dimension. I can split it and then combine it again over here. This is my decomposition. This B to B1 and B2 is decomposition, right? And then this B1 to H is composition, right? I think so, yeah. Then you can see they're doing it in different orders and so on. And this is where I stopped last night. I stopped at saying, I don't know, I mean, water, oops. I stopped at saying that, BH, W1, W2, C. So we've split our width, right? So W2 is 2, W1 is 40, 48, right? So we're saying that our height will become H times W2. The height will be twice, and the breadth will be halved, right? So can you do the reverse operation, height to width? I was too sleepy last night, but I think I can do it. So originally what we have, let's do it in a comment first, right? Originally what we have is a BHWC, okay? Then we can split. So we want the height, so what the question asks for is, can we have the width to be doubled and the height to be halved, right? So you'll do something like B H1 H2 WC, where our H2 equals 2, and then that will turn into B, and sorry, so there's no B anymore, right? So our height has to be halved, right? So we would do BH2, right? H1W C. Let's try that out. I think this should work, but this stuff doesn't work out. Oh, oops. Wow, that's really messed up. Maybe it's this? I don't think it's this, by the way, This is the same thing. So let's see what's going on here. So now I want to do a height to width. Oh, maybe what I should do is see if I can recompress this, right? One. Sorry, we're gonna call this image transform. Just for here we use such one later. Okay. Let's see what's going on here. So let's run the shape of this first. Sorry. Image transform dot shape. Huh? Wow, that's a weird. Oh, okay. So okay, let's look what's going on here. Oh, okay, so we can't exactly rearrange our tuple, I guess. Let's go over to IMS then. Okay, so what we want to do is the same thing as last time. We have our height, which is split in two parts, right? And we want the new height to be halved, right? I know it's doubled. The new height to be halved. What's the half height here is? The half height here is H1, right? H2 is 2. So it should be BH1, and then it should be H2W. This is weird. Why is it duplicating? BH2 H1W. Okay, I want the height to be halved. What's my new height? So it's, but new height can't be B times H, right? B has to be times H1. Why is it doubling? It's sort of this is what I want, but why is it getting duplicated? Let's think again what I'm trying to do here. What I'm saying is that I have a 6 by 96 by 96 by 3, and then I'm splitting this 96 into 2 by 48. Sorry, 48 by 2. Right? I'm saying the new height should be B, which is 6 by, maybe just make it W, I don't know. No, it's going to give me a dimension there, I think, because you have to do that, right? Okay, 6 by, 6 times 48, by the way. What is 6 times 48? Bad math, 288. Okay. H2, 2 by W. I see that. But then shouldn't my width become twice? Why is it getting double? That's what I don't get. H2 is 2, 2 by W is 96 times 2, which is 192, comma 3. Right? Fast ChatGPT in this. I don't want to overuse ChatGPT too much, but we got to go at Einops range explosion. What about this? Correct. H1 equals 48. It's telling me stuff I know already. I know this. Right, okay. 2, 4, 4, 1. Then I split my 4 into 2 by 2. And stop. In my thing, it leads to the image being duplicated. Yeah, I think I'm getting it, but I'm not sure why this is not working. So, yeah, I mean, they're doing it, right? Let's go to Claude, actually. Maybe Claude has better answers for this. So, suppose... Yeah, don't see this. No, don't see my chat. So, explain this Einops to me. This is a particularly stupid answer. I get one lower column. Yes. One row. Okay, correct. It says... I feel like I'm wasting my time with this. Okay, thank you. What about? I thought it would cause the width to double, but instead the images are being duplicated. Okay, that's interesting. It says I should do BH1. I should... Huh. Weird. Let's try it over here. Oh, so this is garbage. Oh, okay. Oh, right. So, the width is expanded by the factor of h2 in the backs. Key difference treats h2 as a sub-dimension of the width. Okay. Oh, it's interesting. This is a fact I didn't realize. H2W. Okay, so this one I think it's because I haven't understood some fact about Einops about this, right? So when we say this, we have 248, correct? Okay. Rearrange 1. The new height dimension is BH1, that's correct. The new width dimension has... Each row of the original pixels is split into 2 height parts. H1 equals 48, H2 equals 2. Can you give me a minimal example I can work out by hand? Work it out yourself too. Suppose I have this small tensor 2, 4, 3, 1. Okay, B is 2 images, H is 4 split into 2 and 2. Okay, so then I say I have only 2 tensors, right? Fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, very easy. first transformation, right? The first transformation is the one which should h2 double, we should double the images. So IMS has 4 of those, which means our IMS has 4 of those, which means h1 is 2 and h2 is 2, right? So maybe I haven't understood this decomposition composition very well. I think my main issue is that I have not understood decomposition very well. Help me start with some basic examples. So let's start. So we split it up into 2 components, right? We decompose single dimension. Tensor. This is our tensor, which is 6, 2 by 3, which means I'll have 1, 2, 3, 4, 5, 6, right? 2 by 3, 1, 2, 3, 4, 5, 6. So maybe we should do that in the Jupyter notebook. Let's go to let's open a new Jupyter notebook here, right? Not sure what kernel I have anymore. So start with the basics. Let's rename this Einops simple. Okay, suppose I have this tensor. From Einops import rearrange, reduce, repeat, right? Okay. Then we do something like rearrange, np.I. I think we gotta do this instead. We have an import np. Import numpy as np. Okay, yeah, I get that. Okay. Recombining dimensions. Okay. Got it. A 2D tensor. Shape 2 by 4. I want to decompose the width dimension 4 into b equals 2 and c equals 2. So 1, 2. So then we will do what? We'll start off as a times bc times abc. So it will become 2 times 2 times 2. So it will become 1, 2. Oh, this is a little hard. Split each row into 2 smaller components. Correct. Split each row. This row is 4. So 4 will be split into 1, 2, 3, 4, right? 5, 6, and 7, 8 with 2 smaller components. Correct. Result: 1, 2, 3, 4, 5, 6, 7, 8, 2, 2, 2. I see. Reversing the process. Okay. You have a tensor. I think this is giving me the same problems. No, I think give me a new problem and make me work it out by hand. Don't give answers. You have this tensor with shape 3, 8, 2. Decompose it into W1 equals 4, the width, and W2 equals 2. This is a really hard one, okay. But I think it's necessary, right? So we have 3 by 8 by 2, which means this is my first, this is my second, and this is my third. This is the 3. The 8 comes from the number of things in each example. And the 2 comes from number of things in each of these, right? Okay. So we want to decompose the width dimension into W1 equals 4 and W2 equals 2. So 1, 2, 3, 4 is going to happen. 1, 2, 3, 4, and 1, 2, 3, 4, right? So we're going to have 3, 4, 2, 2. So I guess, suppose I had only the first 10th row, and and for simplicity add it 1 4 2 2, right? So then what I would do is I would take these 4 over here and put them in 1, right? So then I take the next 4 and put them into 1 more. I think so. It would really defeat the point if I had to like put them in the same row. Split. Do the dimensions match? I mean, I guess. So the friggin' brackets match. 1 2 3 2 3 2 3 2 3 2 1 2 3 2 3 2 1 3 2 3 2 no, these brackets match. This put a numpy array over here. Yeah, these brackets don't match. This is 1 2. Okay, the last one doesn't match. I see. Wait. Okay, dot shape. It's 2 4 2, right? It's not 1 2 4 2. I guess we gotta add one more set of brackets on the outside. That's 1 2 4 2. But we want 1 4 2 2, right? Not 1 2 4 2. So let's go through this again. Okay, so I have 1 8 2, which is this, right? This is my (182). Very good. You know what we want to do is split this into 1 4 2 2 to just visualize how the Einops decomposition works. So what this means is that we have to split this into 4 groups of 2 or 2 groups of 4. Okay, the first action is how many groups to create. So 4 groups of 2. Very good. So then 1 2. So what we should do then is we have this thing over here. We'll be like, hey, this is my first group. My first group is 3 4. Let's make a new bracket around it. Okay, so let's put this over here. Yay, we did it. Right? One more over here, one more over here. Oops, close. One more over here and one more over here. And one more over here and one more over here. Right, dot shape. np.array. Four two two. Right? And then correct. So what you'll do is you'll be correct, that's what I did. Is my first group, second group, third group. Okay, this works. Then for my original, I have this 1 4 2 2, right? np.array, whatever, man. 1 4 2 2. Okay. Instead of 2, 1 4 2 2. Okay, got it. And we want to do this for this, we'll have to split over and over again. Got it. Decompose. Combine the first 2 dimensions into a single dimension 12. Okay, let's do one more decomposition problem. Simple like the previous one. Just decomposition. We have this tensor. Decompose the 8 into this is actually really, I think I would argue too simple. right? So np.array of this dot shape is just 8.1, right? Oops, I pressed anything. I paste it, right? Is 1, 8. And we want to decompose it into two parts, 1, 2, 4. So we'll do np.array. So we want to keep n1, 2 is right. 1, 2. We want to decompose it into 1, 2, 4. Oh no, two groups of 4 then. Sorry. So 1, 2. Oh, I see. We would need this here then. And then we have to enclose the outer one. Alright, so what's going on here? We have two groups of 4 enclosed in a group of 1. This should be at 1, 2, 4. It's 2, 4. Oh, no. I see. Since it's not 1, 2, 4 yet. 1, 2, 4. Okay. Got it. Maybe a little harder. Again, single problem decomposition. Little bit harder. This is our thing 1, 12. Okay, decompose a 12 into 3, 2, 2. Wow, this looks a little harder. Okay, so we have this shape of 1, 12. Just my instinct wants to know if there are any YouTube viewers in this. Oh, one viewer. Hi, one viewer. Who are you? Hi, Sam. Sending. It just takes a few minutes. When he send it? Okay, let's get to it. Now 1, 2, 3. So what they're saying is that I have to make 3 matrices of 2 by 2. Okay, so let's keep this over here. So let's it's 1 by 12, right? It's 1 by 12. So np.array. What did this my 1? This is my 12. Remember, you have to have 2 brackets if you want the whole thing to be 2-dimensional. 1 by 12. Very good. And now we're going to do 1 into 3 times 2 times 2 times 2. So actually what we can do now is we know that 3 times 2 times 2 means we do 3 matrices of 2 by 2 each, right? So 2 by 2 means 4. Let us do a simpler thing first. Let us do 1 by 3 by 4 first. Okay, maybe we'll get that right. Okay, so np.array. This is 1. Right, I'll just paste the whole thing again. Sorry, just paste this internal thing again. Right. Now I want 3 groups of 4. So this is one group. This is my second group, and this is my third group. Right. So this is again just this is just 3 by 4. We have to add the external last airbender, whatever it is. Right. Oh, oops. Oh, okay. Yeah, this is 1 by 3 by 4. Let's check if we are right on that. Yes, we are. Now, this 4 has been now split into 2 by 2. So, 2 groups of 2 then, right? Then I suppose this 1, 2, 3, 4 becomes 1, 2, oops, close it, 3, 4, close it again. 5, 6 becomes 1, 2, 3, 4. Okay, this is interesting. I hope it works out. I think I should be missing one of those, right? I did it. I think this should be it. Is this it? Yes, it is. We got it right. Okay, this is good. We're understanding what it means. So let's go back to the original Einops examples here. Composition of axes. Actually, I think decomposition is more interesting. What we're saying is that we have these 6 by whatever. So let's try and understand this question now. in terms of the thing what we're doing here, right? We're decomposing this 6 by this thing into 3 by 2. So what we're saying is that we have to make three images of 2 each, right? Make 3 images of 2 each. So okay, B1 is 3, sorry, 2 images of 3 each, right? So it's 2 by 3, so it should just be 2 rows and 3 columns, right? So 2 by 3, got it. Got it. So then so let's do this by hand once to see we know what's going on here, right? B. Okay, this is it. 6 times 8 times 4 times 3. This is the 3, right? This is the 4 part, I guess. Like 1, 2, 3, 4. And we have 8 of these in my opinion. 1, 2, 3, 4. And this will close. Oh, sorry, we should have 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. And we can see the thing closing here. This is one of those. And we gotta split it now. I think these numbers too big. Wait. This is more interesting. No, but I want the same shape as the 41. Okay, want to batch this, right? Okay, this is what we have. We have NP.cl. This is a lot more manageable in my opinion. So we have these two. This is we have a channel of 1, right? We have 2, and we have 2 of those, and we have 4 of those. This is like high dimensional recursive thinking. Okay, so let's do this a little by hand, and then I guess we'll just do composition then, and then all of these, and we'll do reduce. I don't think reduce and reduce shouldn't be too bad, right? Then we can get back to the actual Einops in the thing. Okay, let's see what's going on. How long has this stream been going on for? Quite some time, I guess. Oh, hi, 2 concurrent viewers. Hi, concurrent viewers. I enjoy your company. So we have this, and the goal is to split it into, let's comment it out. The goal is to split it into, what is it? 4, 2, 2, 1, right? Into 2, 2, 2. So this 4 gets split into 2. So 2, comma 2, comma 2, comma 2, comma 1. Okay, so what this means is that I have to generate 2 groups of 2. Okay, so I think working high dimension sometimes is like super hard and annoying, but I'm going to do it anyways because I hate myself. Here we have, right? Here's what we have. What's going on? Just press tab. Oops, tab again. Okay, so this is what we have. This is a 4. So I have to take 2 groups of these 2, and then you have to split up. So I gotta make 1 over here, 1 comma over here, comma over here, 1 comma over here, and 1 comma over here. Oh, sorry, 1 comma over here, right? And then I gotta be like np.array this, and then let's check it out. Shape. Yay! I did it. I split out. into the exact shape I wanted. So, okay, I think I can get decomposition now. Let's just see it in the context of this. The problem I was not understanding yesterday. So this is 6 by 96 by 96 by 3. So which means I gotta take 2. Oh, I see now. So I have to take, I'm splitting it into 2 by 3. So what I'm saying is that I'm going to make 2 groups of 3. Ah, right. So 2 groups of 3, so this is how this comes. I see. This is how this decomposition comes. I see. Now let's understand composition. Got it. Now a very minimal composition example. And this tensor 2 3 2, and we want to make it into 6 2. Right. So let us think of it back from first principles. Is there a chat? I forgot. I should be a chat. I should be less worried about my chat and subscribers, but like I'm human, so I like doing this. Okay. np.zeros 232 shape 232. Gotta combine it into 6 by combining this one into 1, right? So okay, let's look at it first. Let's look at this simply. So original, right? Shape 232. Let's print it out. This 232. So like, hey, this is 2 groups of 3, and this is really simple. I mean, just gotta take this thing. Right, this is our thing, and we're like, hey, some guy made it in 2 groups of 3, and we have to remove that barrier. So this one goes. This is out of place then, right? Is it? I think this is it, right? Dot size. Sorry. NP. Let me just restart again. I'm a little confused on this. What's going on here? Oh, yeah. What's going on here is that I have this. This is 2 by 3, right? Let me just tab. Yeah, tab. Good. It's 2 by 3. So what is going on here is that 1, 2, 3. Is that I have 2 by 3. Right? This is my 2. This is my first one. This is my second one. Hey, wait, let's just a bunch of things first. np.array. This whole thing. Dot shape. Or we could just call dot shape. Okay, 2 by 3 by 2. The same thing as before, right? Suppose I delete this. It would just be 3 by 2 then. Oh, I see. We've cut it down. I see. I make it a 6 by 2 now. Okay, yeah, this is 2 by 3 by 2. I make 6 by 2. I mean, conceptually it's very simple, right? Conceptually, just stack all of them in one row. I get that. So you take this, remove it. Take this, remove it. Then you should have to remove these two as well. Yeah, these two match that. So 1, 2, 3, 6. 6 by 2. Okay, got it. I've just undone that. Okay. This is actually quite okay in my opinion. But famous last words, as they say. 2 by 3 by 4 by 1. Okay, let's delete this. Okay. 2 by 3 by 4 by 1. Well, this is the 4 part. I can see that, right? 4 by 1. This is the 4 by 1 part. Right? I have a bunch of 4 by 1 matrices, which is essentially a vector of length 4. I have 3 of those. 1, 2, 3 of those, right? And of those 3, I have 2 of those. So, right. So I need to concatenate these two. So these two should just become 6 by 4 by 1. So this 4 by 1, this stays, right? We still call these 4 by 1 matrices. So let's take this over here. And, I hate copy pasting these. Copy. Okay. yeah, no issues in this. Okay, this is a 2 by 3 by 4 by 1. So okay, I guess. So what we're gonna do is we're gonna say that this becomes 6. So this is my 2 by 3, which means my first needs to become 6, which means I need to have 1. This is the thing. This is, and this one has 2. So I think this one has to go. We're gonna say, hey, bye. Okay, I think this is it. np dot shape, np dot array, sorry, and then do a dot shape of this. No, but oh, what do we just do now? Does this close? Yes. Does this close here? Yes. Does this close here? Yes. Does this close here? Yes. Okay, we have this thing then, right? And then we have it says we have an inhomogeneous part, inhomogeneous shape after 1 dimensions. The detected shape was 4 plus inhomogeneous part. Okay. Okay. This is a 4 by 1, right? This is a 4 by 1. 4 by 1. 4 by 1. I see there's an extra over here. I see the issue. 4 by 1. 4 by 1. 4 by 1. And then an extra one over here, I guess. Yeah, I think this is really an extra parentheses. I'm definitely sure I'm like messing up parentheses over here. Yeah, so we've just combined it in a 6 by 4 by 1 by basically saying that this 2 by 3 was combined over there. Okay, this is not bad. I'm sort of getting the hang of this. Combine the second and third dimension. Okay, this is a very interesting problem, right? Okay, so we gotta keep it 2. It's gonna become 2 by 12 instead. So what we're having here is a 4 by 2, 4 by 2, right? And we gotta make this 12 by 2 instead. I see. This shouldn't be too bad. 12 by 2 means what? So then, tab. Okay, wait, you know what? This one. So this one ends over here. Inside this, so what you can consider it is that inside each of these, you got to make them from 3 by 4 by 2 to 12 by 2, which I've done many times before, right? So, still one concurrent viewer. Hi, concurrent viewer. So this is inside it. This is the array we really care about, and inside this is the part that causes it. So delete it, delete it. Same thing over here. Let's undo the deletes for a moment. Okay, so we're back to where we started. And we know that this is a 4 by 2, 4 by 2, 4 by 2. We gotta combine all these 4s into one massive array. So, okay, delete this and delete this. Delete this and delete this. Delete this and delete this. Right? We keep this. Okay? Delete 1 here and delete 1 here. Delete 1 here and delete 1 here. Delete this and delete this. Yay, I think it should work. np.shape. np.array. Why do I make this stupid mistake? np.array.shape. I did it. I think I have an intuition for how Einops works. I say I think because this is like deceptively simple. Okay, it's 10:35 now. I think I should be about an hour done. I'm not sure. Let me open the YouTube stream and see how much um, time has passed since I started this. Okay, it's 10:35 now. I think I should be about an hour done. I'm not sure. Let me open the YouTube stream and see how much um, time has passed since I started this. Okay, it's 10:35 now. I think I should be about. Lol, you guys can see me seeing the video, or at least hear the video from me. Anyways, I'm going to take a break. Hi Karthik, nice to have my friends be my concurrent viewers. I'm going to take a 5 minutes break because my brain's kind of fried. And so see you in about 10:42 p.m. a.m. SGT. Oh, the 3 concurrent viewers. Hi 3 concurrent viewers. I really enjoy your presence. Hi 3 concurrent viewers. I greatly enjoy your presence. However, Einops has fried my brain, and I will be taking a 5-minute break. It's sending. Sent. Okay. I'm just going to check my phone and texts and so on, and then we can get back to work. I'm muting myself. I think that's not supposed to happen. I think I have some sort of issue with my screen share. So let me fix that. Okay, I think it should be back on now, except for I guess some zoom is off. I have no idea what's going on here. Yeah, what's happening to my video? I think it's a matter of why is it so bad? What's going on here? No. Okay, let me go to screen capture, go to properties, go back to the defaults. Yes, please go back to defaults. Window capture. Okay. No, something's really gone wrong with this. I see. I have messed up somehow. Don't rotate, please. Just walk normally with me. I see. Okay, I think I'm fixing it. Can you see it? Let me go to my own stream and ensure I can see it. Don't rotate, please. Just walk normally with me. Okay, let's get back to work then. And now here we are. Give me a minute. I need to get my brain back to being not brain dead. Okay, we're no longer brain dead. Let's get to it. Now, we just finished doing composition and decomposition Einops. So we get to this, right? And that's because I didn't get out why this didn't work. Why these two produce different things. So let's try and understand this now with our new knowledge. Let's try and understand these ones again. Composition of axes, right? So what this is saying is we have BHWC and we have to HBWC. So the height axis, so we consider this as 6 times 96 times 96, this big matrix of 96, and 3 values inside each, right? That's our thing. And so we're saying is that the width axis, right, the width axis has to be combined with the batch axis. So we're saying that I'm not sure why this works, man. Wait, let's think through it slowly. BW, okay? So B is batch, so width. And what we're saying is that the width axis has to be combined with the batch axis. And so we're going to do WB on this. I'm actually curious. WB. Wow. This is really, really weird. Okay, so BW says that, we have 6 times. Oh, okay. I think I get this. So BW will say I have 6 times of these 96 things. But WB will say I have 96 times of these 6 things. That's not true. I have 96. I have the width, like the thing we multiply with, should be it. So let's go and understand this, right? This is IMS.shape, which is 6 times 96 times 3. And then we have rearrange this, which is, right? So this gives me height is the same, but I have 6 times width. But the same thing, WB gives a distorted set of images. So, okay, distorted. Correct. BW are combined to a single dimension. You stack the pixels of each, correct, right? You take those 96 and you make them go 1, 2, 3, 4, 5. You can't see them. 1, 2, 3, 4, 5, 6, right? Height stays the same. Which means you take one pixel from each image and horizontally interleave the data. So what we're saying is that, just this. Can you explain this again? How does the interleaving happen? How does the interleaving happen? So we have this, okay? Correct. WB is the width of one image, is the width of one image, and B is the batch size, right? We get this 96. So we're saying for the first pixel of W equals 0 of all images, we take the pixel values and put them side by side. Huh. Okay. So wait, okay, wait. The two similar but different changes I asked to compare. Okay, 6 by 96. Right? Okay, this is the good one. Width and batch. We're saying for every position in the width, W equals 0, W equals 1. We're saying for every position inside the width, okay, for the height equals 0, take the first pixel of W equals 0 from all 6 images, image 1, image 2, image 3, and so on, right? I see. So the first row becomes the width of all of them stacked, because then we'll have, right, so that makes sense because we're taking all the 96 and stacking it by 1, right? There's all this 96 by 6 and stacking it by 1. Whereas on the other one, we're taking the first 96, the second 96, the third 96, the fourth 96, and so on. Okay. The first column of pixels from all images and placing them next to each other. Right. So the original image 1 will have 1A, 2, 3. Yeah, okay, got it. Fine. I see what is happening. I see. That's 2 times width. We gotta take it. Okay. Suppose we want to do the opposite. They do this. So what they say is that they take height times W2, which means they take height times W2. Okay, which means that this is a little confusing, isn't it? We're saying that the height is now enhanced by 2. So the height becomes every single thing. Okay, now I explain this then. We've done this sort of split before. We take the W2, inside the widths, we split it into groups of 48 groups of 2. Right? We split into 48 groups of 2. So what's happening is we have this W times C, right? We have this W times C over here. And so inside these two, we have a 48 times 3. Sorry, 96 times 3. And what we're saying is that we have a row of 96 elements, each of which have 3 elements inside, 3 numbers inside, right? 96 elements, each has 3. What we're saying is we're splitting it into saying that each row will become the first 48, next 48. First 48, next 48. That's what this thing does. Okay? So, okay. That's what this thing does. Then the reorder will say that, hey, this okay, got it. That's what the first thing does. So the first part of this splits a row of 96 into 2 rows of 48. Just the W split, I mean. No. Oh wait, it's 48 by 2, right? W2 is 2. 48 rows of 2 items each. Right? So you will get 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Am I showing the right thing on my thing? Oh no, I'm not. There's an issue. I see what the issue. I see what's happening. Okay, wait. I see why this is causing the issues. It's because I'm combining a YouTube live control panel and zooming in and zooming out. So the whole thing goes oddly. I don't know why this is stalled, but let me. This is really buggy. I don't like it at all. Okay, so what's happening? 1, 2, 3, 4, 5, 6, 7, 8. That's what I'm talking about. Okay. Yeah. Then I guess. Okay, that's one part of it. Okay. That's done. Right. Now what's going on here is that. Okay, I got this. Now this W1 and W2 is distributed among other dimensions, right? Let's try this itself. Okay, you know what? We should try this out. We have that, but I mean we keep the hatch, the B and hatch. We just do it as W1, W2. Okay. Oops. This is called a column, right? Okay, so shape is this. I agree, right? Rearrange the dimensions. Okay, W2 to height H. Okay, this is our thing, right? It's 2 by 4 by 4 by 1. Let me first do the first split, right? W1 to W2, and we can split, I guess, 4 and 2 and 2. So this will become 1, 2, 3, 4, 5, 6, 7, 8, so on, right? Correct, got it. This is a hard part, right? So W1, W2 becomes HW2, which means, let's do an even simpler example. Simple, 2, 1, 2. Okay, if I apply the first transformation, we split into W1 and W2. This, so it has one part into which 2. This is only one part, and it has 2 parts, right? We split into 2, where W1 equals 1. I'm just gonna add one more line, one more. Still stays 2. I don't get how the tensors move around in the second half of the composition. Okay, there comes 1 by 2 by, and this has by 1, 2 by 1, and then that by 7, 1 by 2. The height dimension is stretched into 2 rows, one for each value of W2. I see, okay. So HW2 is combined, right? What does that mean? This is my H was 2, 1, 2. My H was 1, right? So then my H becomes 2. So I will have, this is really confusing, man. H becomes 2. Oh, Karthik sent me a message. Yeah, I'm reading his message. No, I think my thing to Karthik is that if the dimensions are next to each other, I'm okay combining them. But they come from like randomly across. I'm having an issue with that. Yeah, I think that's a good thing to plot also. When the dimensions are next to each other, I get it. Because it's combining matrices. But when they're apart, like H and W2, I'm confused. The whole tensor, okay. This part I get. Non-adjacent dimensions. For image 1, right? 1, 2 becomes 1, 2. C4, correct. After combining H and W2, first value from H equals 0 is W2 equals 0. Second value is H equals 0, W2 equals 1. I see. 1, 2, 3, 4. Then it'll become, so 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I see. Can you do another different example? I would have text that I need to attend to, unfortunately, or fortunately, because we split the H, right? So H becomes, so H right now is 2. We're going to split it into H1 equals 1 is 2. We're going to take one group of these and we're going to say, hey, y'all are 1 now. So this is our B, and this is our, B is only 1 at this moment, right? So that makes it easier. So we have 2 times 2, essentially. I'm going to split it to 1 times 2 times 2. So this 2 times 2 is this whole thing, and we want to say 1 times 2 times 2. So the, this is the 2 times 2 part, right? 2 times 2. When I say 1, I mean, you can just put a 1 extra bracket over there. That's pretty much it, right? Conceptually, yeah, now I get it. Rearrange dimensions. Now we have that, right? Becomes BW. So we combine B and W, most annoying. So across each image, we have image 1, okay? BW. So 3 times 2, which is 6. Okay, I get that. Which means that we stack the pictures horizontally, pixels horizontally. Okay, what does that mean? BW. So B is over here. Right, across an image is this, right? BW. So batch 1. Okay, so I see. So it's 6, which means batch 1 I gotta do with 0, 1, 2, 3. So batch 1 with 0 is 1. Batch 1 with 2 is, okay, I see. Oh, it's 159. How the hell do we get 159? Batch is 3. Batch 1 with 0 is 159. Okay. and batch 1 with 2 is, sorry, the numbering is off, 0 and 1, whatever, you get it, 1 is 2, 6, 10. I see. Then batch, no, batch 1 with 0. Batch 1 is this batch. Oh, this is hard. This is hard, dude. Okay, I think I have some intuition now, given I was able to do this. So I've let it go, and we'll move on to Einops reduce. Okay, I can feel my attention span dying, like very, very fast. So I can really, really feel. I want to check my phone, I want to do something else, I want to, whatever, etc., etc. Okay, I think I sort of get it. We can stack, and then we gotta reduce. This is like pooling, right? I guess. Yeah, I've done this when I do a CNN. Average over batch. Oh, neat. We get the average over all of these. I see. Ah, yeah, I can see what they mean. This sucks compared to this. I know what this means. Uh, Doing multi-dimensional thing is hard enough. We reduce over batch and channel. Wow. We're taking the min. Well, how about, what about we taking the mean of this? Same thing, right? Oh, okay. Some issue happens here. How do I... Are these two the same image? Okay. Okay, got it. This is obvious. You can see that there's color here but no color here. So we've compressed the... Yeah, got it. So I get mean pooling with a 2x2 kernel. What does this mean? I don't get it. Lol. I know how a kernel works, but I don't know how these Einops lead to a 2x2 kernel. H2 is 2, H is whatever is whatever. This is annoying. H1 is here. This is going to hide H1. W is W1. Right. We're calling it H1. H1 is half the height, right? That's half the height. B times W1 means we stack up 6 of those, and B times... I don't know what I'm doing here. It's okay. Patches. Oh, I see. So number of patches, number of horizontal patches, and size of each patch, right? So then we say, hey, we want a horizontal patch of H1. We want a B1 times W. Sorry, B times W1, and then we say that, hey, whatever is in between these, we lose impression. How do we deal with it? Mean it. Makes sense. Makes sense. Makes sense. Makes sense. Yet another example. We're doing B1 and B2. We're splitting across these. Okay, B1 times H. So this is 2 by 3, right? So we're saying that, the height should be 3. We should have a column of 3, row of 2. And we should mean it across those, which means, that's odd. It's really, really odd. The mean is applied across the B1 and B2. So no, I get that. And we're losing our C dimensions. The C is definitely collapsed into. It's losing color. Okay, that makes sense. Stack and concatenate. This shit's hard, dog. Ugh, okay. I think I'm okay enough with Einops right now. I think I'll get more familiarity with it as I get better. But I'm not gonna do any of these. Okay, I'm not gonna do any of these, but what I am gonna discard, save. What I am going to do now is I'm going to go to the arena material, which is my original purpose of here. Right, let's check my stream's working properly. Yes, it is. So, arena Proteum now. Let's go to this prerequisites exercises and get to, wait for the collab to load, open this in collab. Here, okay. Let's also, one watching now, 90 minutes ago. Okay, so right, let's start now. So let's start. We already did this. Don't read on anyways. There should be a thing which says save to GitHub though. Why am I not getting the save to GitHub? It's really annoying. Oh, okay. Only after it connects, this shows up. I see. Save to GitHub. Keep changes. Enter. Here's where the fun part starts. I think I should just runtime. Please interrupt. Thank you. Thanks. Print testing. np.load. Yeah, that's something. Import fuckery? Probably said that. Please work and don't crash on me. Looks like it worked. Yay, we did. Hidden, okay. Works, right? Try for at least 5 minutes. Okay. 45 minutes collectively. Okay. Display solution. They want us. So let's look at this ARR over here, right? Let's look a little math here. Okay. So it's a solution. Oops, we shouldn't be seeing solution. How do I hide the solution? Anyways, so we know ARR. Where is it? Shut up. ARR is over here. Do it ARR shape maybe. Okay. So this is batch channel height width, right? So then we should do AR1 equals Einops dot reduce, a batch channel height width into. So what we want is we want to keep the height should stay the same, right? So so here's let's look at the simple idea of this. We want it in the form height width, sorry, channel height width, I suppose. Right, because here the channels are in the first and the 0 and the 1th dimension. So what we want to do is the width should become that. So then this channel stays the same, this height stays the same, but we get BW. I think this is how this thing works. Any others? I just did that. Huh? What the hell? Well, why is the difference here? Oh, no, not reduce, sorry. Rearrange. My bad. I just had a pattern here. Oh, ARR, comma. Let's try again. Pray to God it works. Kaboom, it worked. Is my thing more bloody than theirs? I don't think so. We did it. Yay, we did it. 109 cells hidden. Exercise 2. 0, 0, 0. Okay, just 0, 0. Huh. I feel like my education has not prepared me for this. Okay. Whew. Yes, I'm taking a break. My brain is too fried to do any of this. Okay, a lot of people are liking the stream tweet, so I have to like actually do it. Display solution array as image 2. So original array is like this, right? So we want to take only the first batch, right? We want to take the first batch only. Okay, so let's, this is a little hacky, I guess. Sorry. So AR2 equals AR temp equals ARR colon 0, right? Works. ARR temp dot shape. Correct. And now I gotta repeat this somehow 2 times. There's a stack in Einops, right? You can stack things. Like how do I stack things? Like I just stack inputs. So, no. So I just need to stack it, right? Wait. I think I'm feeling this. I just need to take 1 0 over here and then stack it below over here. Are you guys seeing it? Yeah, you guys are seeing it. So then I have okay, let me just look at this. So I didn't really do a stack and concatenate better. Ugh, this is painful. How do people do this? It's okay. Wow, there's a lot of exercises. Torch, Einops, temperatures, identity matrix. God curse me. I have done very, very hard work. Okay, so let's do this now. Let's do this a little slowly. We gotta stack it, right? Let's stack it. So, how have we stacked it? But no, I can't stack it because it's 0, 1, 2, 3. Right. Just now, we made that stupid mistake where we did this double, right? How did this happen? So let's try a few things, okay? Sorry. What happens here? I'm just curious. Oh yeah, we gotta figure out one thing, right? H2 equals 2. H2 equals to 1 minus 2. Not being visualized as a what the hell? Oh, display solution area as image. Now let's look at this carefully. Okay. It is failing. It is failing. But I do not get general idea, so I have to continue. So let's try and think of a general idea. We have 6 images batched over here, right? The color is the channels are like 3, I assume. Let's go back a moment and do arr.shape. I don't know why they did it like that, but then what we want is we want 0 and then 0, right? So let us do something even stupider. Oh, we made a mistake then. We have something over here. We did the same thing. Okay, that was a mistake last time. So this is because I've cut over the height axis, right? How about I keep the height okay? I say it's height, but I cut down by the width axis. W1, W2, W2 equals 2. Okay, and then channel stability stay the same, right? My height should also stay the same. No. What I want to do is see that, hey, we have W2 times H and B times W1. I have something like it. Now I just need to take the first part of it. I have something over here, right? What I'm saying is split my width, and I tell my width is now half the width, and then the width 2 times height. I keep my height to be W2 times H, right? I have something, but I think what I need to do is that I need to. What does numpy.stack mean? Let's look at that. What is np.stack? Oh, oops. English is gone. Okay. Oh, but how about I have a very stupid idea, but how about can I take one image as an array, copy it, and then stack it above to get 2 images in a column of the same image. Yes, that makes sense. Okay. So what we should really do now is this sounds really dumb, but I'm going to take AR temp and stack it over AR temp. .vstack. There's a vstack in NumPy, right? Okay. So AR underscore temp. Right. Now how do this using Einops? I don't get how to do this using Einops. I'm not sure what I would do. Hi stream, we're 105 minutes into this, and I am not progressing on my thing. Yeah. Let's look at this instead now. Same thing. Stretch, right? The height times 2. How the hell do I do this? This I can do. They take the mean over the... Right. They just concatenate, just mean it over everything, channel and batch. What the? What in the... This is a hard one. This has some sort of like meanish, or like some sort of, yeah, some sort of pooling, I guess. Okay, okay, I see, I see. Okay, here's the deal. I feel like my brain is fried now. I'm gonna end the stream, and I'm gonna get some food or something, and then I'm gonna